Now in this video I want to talk about a thing called the definite integral. Now the last video we were doing the indefinite integral, it had that plus c on the end. This time we're going to do a situation where we do know the value on the end. Well, it's not necessarily to know what the value on the end is. What does it mean? Let me just work through this scenario for you as an indefinite integral, and then I'll make an ever so slight change to turn it into a definite integral. First of all, integrating that. It looks a little bit strange with the dx on top of. What does it mean? It's easiest to rewrite it like this. It's the integral of 1 on x squared with respect to x. That's what it means, that's what it looks like. Integrating that is a bit of a pest when your unknown's on the bottom. So priority 1, move it to the top so it becomes x to the negative 2. We can integrate that quite easily by our integration rules. So from there, x to negative 2, increase the index by 1 to become x to the negative 1. Divide through by the new index plus c. And so over here, that's going to give us, move that x to negative 1 to the bottom, becomes x to the positive 1, include the negative sign, voila. Here is the indefinite integral of 1 on x squared, because this function, the derivative of it will give me 1 on x squared. So there could be any one of an infinite number of values for that constant on the end. But I'm going to do a situation now where we're not going to need that constant on the end anymore. We're going to have a look at a question like this one. I'm going to put the numbers 0.1 and 3 there on the integral symbol. And we'll talk about what that means. So if I were to graph 1 on x squared, it looks like this. Now the 0.1 and the 3 refer to values on the x-axis. And when you do integration, what it actually does, it finds the area under curves. So this means, what is the area under the curve, 1 on x squared, between 0.1 and 3? Well, when we say under the curve, technically what we mean is between the curve and the x-axis. So integration will find this area for us. So what's it, 0.1 to 3. Now once we've done the integration, we can start to incorporate the 0.1 and the 3 like this. Once we've integrated to get this particular function, square brackets in, keep the 0.1 and the 3. So up here, square brackets at the 0.1 and the 3. 0.1 and the 3. Notice I've left the c out. We don't need the c anymore, because what I have here now is a very simple and easy way of finding the area under this curve over the stated domain. From here, all we need to do to solve this is we take our 3 and substitute it into our function, so negative 1 over 3. From that, we remove, put the 0.1 in there, so it's going to be negative 1 over 0.1. I could have included the c in both of them if I wanted to, but hopefully you'll be able to visualize that c, take away that c, regardless of what the constant is, they're going to add out, it's not going to make any difference. So here we have negative 1/3, take away a negative is a plus, 1 divided by 0.1 is 10, that gives me 9 2/3. So the area under this curve between 0.1 and 3 is 9 2/3 squared units. And that's what integration is for. And when you've actually got definite values there on the integral symbol that you no longer need the c in your calculations. And that's our definite integrals.